VSCPR theory basically. Any 2 or 3 points would be suffice. I need to see
Um,
whether you know or not.
I do not know.
Okay, when was the last time you revised this or even looked at the PDF? Like the
Like
last week?
last, like last, like last Friday,
It is wrong, you
not
know.
this Friday. Huh?
It is wrong. Like you won't
I know,
find the
but
chapter
the
harsh.
family issues was too harsh.
Okay, no worries. So let us start with the limitation. The VSCPR theory is very simple. I think you will be able to understand by just giving it a read because when I was teaching you those, no, you were responding in a very proper manner. So I think if you give them a read, you will be able to understand. So do one thing, open the PDF sideways, like so you can go through it.
Yeah.
So the limitation, okay. The VSCPR theory was able to explain shape of simple molecules, but was unable to predict the shape of number of cases where Sn is 8 or greater than 8. What do we mean by Sn 8?
SN. Okay. Steric number.
Yes.
Um, Steric number is greater or equal to 8. So that means it has 8 single bonds. Like, I mean,
Mhm.
sorry, sigma bonds.
Okay, you can say that.
Um, or there's some like what do you say? Lone pairs.
You can simply say 8 species are surrounding a central atom, right? If it is
Yeah,
8,
eight
then 8.
species.
Yeah.
Can we say 8 species?
Yes, because like before 8 till 7, VSCPR3 is valid. But as you reach more complex compounds, this theory was not able to explain their properties properly. It was having trouble elaborating about the properties of compound which were surrounded by 8 or more molecules, or sorry, 8 or more species basically. It could be atom, it
Mhm.
could be a lone pair, right? So what is the limitation of it? It cannot explain the molecules with steric number 8 or more, right?
Yeah.
So till this point, we studied Lewis and VSCPR theory. Both have drawbacks. Till this point, we studied Lewis dot structure and we saw its limitation. Then we studied VSCPR. Then we now saw its limitation as well. So let us try to understand how we have to proceed from now on. Lewis' approach helped in writing the structure of molecule, but it fails to explain the formation of chemical bond, right? It also does not give any reason for the difference in bond dissociation energy and bond length in molecule like H2 and F2. If you see the bond dissociation energy for H2 is 435.8 kilojoule per mole, but for the case of F2, it is 1506, 150.6. So a question for you, out of like between H2 or F2, which bond would be easier to break?
Easier to break.
Yes,
Um, Easier to break. Yeah. So
hmm,
F2.
great. The reason is what?
Um, because H2 would be hardest because it needs one electron to make a full octet. And plus it is close to nucleus. So
You are relating Zeph, but here I have given you data. Like if you need to
yeah,
break H2 bond, you need to spend 435.8 kilojoule energy. On the other hand, if you
yeah,
have to break F2 bond, you have to just simply provide 150.6. If you like talk in terms of percentage, it would be around how much? Mm,
percentage.
yeah, like how much is 150 or 435? So whatever the number you're getting, it is that percent, like less percent, right?
uh, yeah,
So our Lewis was not able to explain this, like why this is happening, right? VSCPR
yeah,
gives the geometry of simple molecules, but theoretically it does not explain them. And also,
Okay, now I understand. So, it needs 435.8 kilojoules moles to separate them, you're saying,
yes,
right?
if you need to break H2 bond, basically you need to provide this much energy.
And F2 needs 150.6 kilojoules.
Yes, it is relatively very less.
Yeah, but how, like, it makes sense, no? What
It makes
didn't
sense.
he,
Ah, you are able to make sense because you have a broad idea basically. You have seen the theories which came after Lewis as well. But at the time of Lewis, I think in 17 or 1800s, he was not able to explain this because
oh,
you
he
have
was not
all the
able to explain why hydrogen
Hmm.
atom is harder and why F2
Yes.
is not harder.
You have all
Okay.
the cards, like you have all the parts of the puzzle now. But at his time, he was not able to see like the reasons because he
Yeah, he
had
has
limited
no
knowledge.
cause, no
Hmm.
idea,
So
nothing about Zeph. So, Lewis didn't even know what Zeph was?
he knew Zeph was like, see, he was not able to apply it properly. Are you getting what I'm trying
Okay.
to say?
Yeah, yeah, yeah.
The
Apply
next
properly. Hmm.
VSCPR theory gives the geometry of simple molecules theoretically. It does not explain them, also it has limited application. You cannot apply VSCPR theory on all the molecules. It is limited to certain molecules. As we saw, steric number 7. Till steric
Hmm.
number 7, you are able to use VSCPR theory, but if you are
Yeah.
going for even more complicated
If you go
molecules,
more than seven, it's not explainable in VSR
yes.
theory.
So
VSR.
we collectively saw the VSCPR problems and Lewis problem. So now
Mm-hmm.
we will try to solve them. To overcome these limitations, the two important theories based on quantum mechanical principle are introduced. So to explain these problems, we are now going to take help of quantum mechanical models, right? So the two quantum mechanical model based theories are VBT, valence bond theory, and the other one is molecular orbital theory, right? These theory
Yes.
are able to explain the points which were missing in Lewis as well as VSEPR. But here we are going to use quantum mechanical models, right? So
What's
let us talk.
quantum mechanical? What?
Basically, these two theories involve quantum mechanics.
Oh, okay, okay, okay.
So what is valence bond theory? So let us talk about valence bond theory first.
Mm-hmm.
When the two atoms of an element are far apart from each other, there is no interaction between them. When they come closer to each other, new forces come into operation. Suppose I have these two atoms. They are far apart from each other. They are not in their what you can say attractive forces region, right? They have no idea like another atom is existing at some far distance, right? But as they are moving
Uh,
close to each other, they are coming into their attractive force fields. So now they are experiencing some force, right? Or not?
yes.
So as they are moving closer to each other, they are experiencing new forces that are coming into play. So let us talk about those forces. What kind of forces are?
Hey, whoa, just a minute. They don't even know whether there's another atom nearby.
Yes,
But
because they
how
are
are they
far away from each
attracting?
other. See, the atoms are not stationary. They are always moving from one place to another, right?
Yeah.
So if I am at a far away position and I am constantly moving, so there might be a point where I meet some other atom as well. And as I will
Hmm.
move closer to that atom, I will experience its own electric field, and my electric field will also interfere with its like they will basically have their attractive force field uh, interact with each other. We can say.
If
Suppose
that's true, then won't it be more complex than you think? Like
It
it's
is
keep
complex.
moving and it will keep attracting atoms, so it will grow into a
Hmm,
big atom,
it is
a
complex.
molecule.
Huh. Complexes are not just made up of two or three atoms. We have very, very more complex atoms. And to be honest, the complex that we actually use, suppose you are making some medicines, right? So the complexes that we are using in medicines, now they are very complex molecules. They consist of like, I would say 50 or 100 atoms in just a single
Mm.
molecule or compound. So the things that we are studying here are just simple examples to let us understand what is happening. So we can like if you know the basics, then you can only go for the advanced problems, right? So this is
Yeah,
basics. If you look like try to search any complex any medicine like any medicines molecular structure, you will see the molecular structure is very complex for even most basic medicines, right?
yeah,
Suppose now this atom is coming closer to this one, right? Suppose
yeah.
this had its own its own fields, electrical and magnetic fields, right? And the
Yes.
other atom has own electric and magnetic fields. As they will come closer to each other, these fields will interact with each other or not interact with each other.
Yeah.
So let us talk about the new forces of interaction or attraction that are coming into play when the atoms are approaching each other. So let us talk about it. The force of attraction, I am reading this point. The force of attraction between the nucleus of one atom and electron of other. The first type of interaction, or to be more specific, attractive forces that we are going to observe is between uh
Two atoms.
between two atoms. The first atom's nucleus and other atoms electron. Suppose this is my first atom, this is my A, right?
Mm-hmm.
It has its own nuclear charge. This
Mm-hmm.
nucleus will exert some attractive forces, and this another atom which is coming closer to itself, this one has electrons. So this nucleus will attract the electrons from the other atom. So the first,
By using effective forces.
yeah, it's nuclear charge basically, right?
Nuclear charge.
The positive charge, the charge developed due to the protons, the nuclear charge.
Oh, so negative and positive
Yeah.
attracting each like that.
Mhm.
Okay, okay, okay.
So the first type of new attractive forces that we are observing is between one atom's
Uh,
nucleus and other one's electrons.
yeah,
And
nuclear charge.
the opposite is also true. Suppose we can also say this atom's nucleus is
This
also
atom's
attracting
nucleus is attracting the electron from the other
A as
one
well, A as well,
atom.
right? Now, let us talk about the other type of force. The force of repulsion between the nuclei of these combining atoms and between the electrons of these atoms. So I would request you to think about this point and tell me what can you understand by
Yeah,
this.
that was a yeah. I understood before I read this. I
Mhm,
think. I don't know.
mhm,
So my question is, I'm just gonna ignore the second one. Let's go to the first one. And my question is, won't it repel
mhm.
because there's negative and negative electrons?
Yes,
Negative electrons and other negative electrons can repel, and a positive nucleus and the other nucleus can repel. So won't it
yes.
repel?
Yeah. The second point is about your statement. Like there are two types of attractive new type. There are two types of forces. Like basically the first one
Like
is attractive
attraction and
forces
unlike attraction.
and repulsion, you can
I
say.
mean repulsion, yeah. Unlike a repulsion.
So the first one is attraction between nucleus and electron, and the second one is repulsion between the corresponding electrons
Two
and their
nucleus and
nucleus
two
themselves,
electrons.
right? So this note, let us see what it is saying. If two atoms want to make a bond, the attractive forces must be greater than the repulsive forces. So as per VBT, as the two atoms are approaching each other, they will experience both types of forces, attractive as well as repulsive. But if these two atoms wants to make a bond, then the attractive forces that are playing a role here must be greater in magnitude if you compare them with repulsive forces, right? The
Mm.
attractive forces should be greater if you want to make a bond between these two atoms. This is what BBT says. Is it clear?
Yeah, so basically the electrons should be less in one of the atoms.
It is not necessary. Like you have to get a data in numbers, magnitude, right? If the repulsive forces are suppose 50 kilojoule, right? And the attractive
Yeah.
forces are 60 kilojoule. So there you
Oh,
can make a bond, right?
oh, just like that. Okay.
Mm.
Numbers. Okay.
So this is a question in your NCRT, question number 33. They are asking, explain on the basis of VBT why hydrogen molecules are forming a bonds. If two hydrogen atoms are approaching each other, why they are making a bond, you have to explain in terms of VBT. So let us understand what is happening when two hydrogen atoms are coming closer to each other, right? So try to see it carefully. This is
Oh,
hydrogen B, this is hydrogen A, right?
okay.
Now, this is hydrogen
Electron.
A's electron, this is hydrogen's B electron, right?
Oh, yeah.
Now, the old forces we have shown by this dotted region. The old forces are
Old.
old, the ones which were present even before the two atoms are coming close to each other. Suppose I am existing here without knowing there is some other atom, right? So once
Yeah.
the point where I am not interacting with any other atom, there are some specific forces that are still present inside the atom. The normal forces, the forces between nucleus and electron. An atom, an atom has its own nucleus and its own electrons. So if it is not interacting with any other atom, when it is isolated, still it will experience some forces, attractive forces, right, between this nucleus and this electron. This force is going to be present even before it is
Yeah.
interacting with some
Yeah,
other
yeah,
atom.
yeah. It will attract the its own electron also.
Yeah,
That's called Zeph.
yeah, right. This is there.
So dotted lines are belonging to one atom, and the straight one belongs to another atom.
Uh, to be more like to understand it better, you can say the dotted lines are the forces of interaction when the other atom is not in the picture. These dotted
Okay.
lines are at that point where the other atoms are not coming closer. So when the other atom is coming or approaching the atom, the previous one, so they will experience some new forces of attraction as well. So the new forces are what? Now, this hydrogen atom B will attract the electron of A as well. Are you
Okay,
understanding?
now I understand. Okay, so new one is the another atom attracting the old the okay, now I understand. So all forces is a force between one atom, electrons and the nucleus
Its own
between one
electron.
atom.
Mm.
Its own electron, yeah. Um, but new one is like another atom has just newly came and wants
Mm.
to attract. So that's
Yes.
new forces. So the nucleus from the another, like we studied above,
Mhm.
that happens in new one. Yeah.
Yeah, it is what you said. It is that only, right? So there are
Yeah.
how many type
Okay.
of
Now I
forces
understand.
involving here now? Four type of attractive forces, two old ones and two new
Yeah.
ones. So we have four types of attractive forces. Now let us talk about the repulsive forces. So the repulsive forces are between the nucleus and the two electrons, right? The electron of A will repel electron of B. The
Yeah.
nucleus of A will repel the nucleus of B. So we have total two types of repulsive forces. So you can clearly see the attractive forces are more in number if you compare them with repulsive forces.
Yeah. There's
So
four,
this
and there
this
there's like two.
this is the reason why H2 exists, right? As
Oh.
per VBT, the attractive forces are more if two hydrogen atoms are coming closer to each other, the attractive forces are more if you compare them with repulsive forces. This is the reasoning of VBT. It uh, is like that's why H2 molecule basically exists. Right. So let us see the theory as well a little bit. The things that we have talked about, the same thing is written here. So let us see. In case of H2, the magnitude of attractive forces is more, 4 attractive forces, than that of repulsive forces. Thus, the potential energy of the system decreases and molecule of hydrogen is formed. Right?
Yep.
Let us see in terms of this. This is a diagram. This is a figure basically from your NCRT, and it is very like helpful to understand the concept. So let us see. The note, let us read this one first. Potential energy decreases due to the attractive forces. Potential energy increases due to the repulsive. Right? So let us see what is happening here. This is my energy. On the
Huh.
y-axis, I have my energy. On the x-axis, I have my internuclear distance. What do we mean by internuclear distance? The distance between the two nucleus of two respective atoms. Right? So try to understand it. Right? This is my zero. At this point, the
Yeah.
energy is zero. And as we are moving here, the energy is decreasing, which is good for us because as the energy is low, my bond or atom will be more stable. So try to see here at case 1, when atoms are close to each other, but they are not merging with each other, right? They are just in close proximity. They are not touching each other. So the potential energy is
Okay.
what? Potential energy is
Potential energy is
zero,
like zero.
you can say, right?
Yeah, yeah,
As
yeah.
as
Near to close to near. Close to zero.
as the atoms are just meeting each other, like they are coming into their electron cloud. Their electron cloud are touching each other, right? So what we are
Yeah.
observing, the energy is even decreasing. The energy is decreasing even more
Decreasing.
because now we have 4 types of attractive forces. At this point, there are 4 types of attractive forces now. And what if, and as we are moving, like as the atoms are moving even more closer to each other, we are seeing a point where the potential energy is minimum. The potential energy is what?
Minimum.
Minimum. But once they are so close to each other, like their nucleus is about to touch, like their nucleus is about to, their is like corresponding nucleuses
Collide.
are about to touch each other. At this point, they will repel with very high intensity because suppose I am forcing 2 atoms to come closer to each other, right? At some point, the repulsive forces will dominate. Thus, repulsive forces will be uncontrollable. And at that point, what we will observe? A sudden increase in potential energy. And this increase in potential
Uh,
energy is suggesting us that now atoms are going away from each other.
mm.
What we can say, too close, repulsion dominates, hence potential energy suddenly increase. Are you getting what I'm trying to say? Suppose
Yeah.
you have 2 balls, right? Two elastic balls. You are like what you can say, you are uh, pushing them with each other, right?
So it's like
So
a magnet then.
not a magnet. You can say in terms of magnet, but you have to go into the like their magnetic properties changing when they are coming close to each other. So to imagine it in a simple way now, suppose you have some elastic ball, right? 2 elastic balls. You are forcing them to come together, but at some point they will not go even further. Suppose, how can I explain it? Do I have some sort of GIF? Do you have some like? Can you think about an example? Like how can we?
Yeah, magnet.
Okay, go ahead. Then explain how can you relate it with
So
magnet?
I kind of understand, but
Mm-hmm.
I'm gonna say what I understand.
Go.
So as the magnets, I'm gonna take it as magnets. As the
Mm-hmm.
magnets is like not interacting, um, they don't have, so their like energy is like close to zero. Okay,
Yeah.
like almost zero, right?
Mm-hmm.
But if we start to bring it together,
Mm-hmm.
just a minute, just a minute, just a minute. I have something, just a minute. Give me a minute.
Think about it.
No, I'm not thinking, just 1 minute. Yeah. Um, okay. So as we bring it together, the energy like decreases. For in magnet it increases, but in electron it decreases.
Yeah.
But what? Why did I relate with a magnet? Is that when it is colliding, the repulsive energy increases very much that they want to repel so bad. So the
Mhm.
energy becomes a potential energy. That's what I understood.
Okay,
Like high
okay.
energy.
See, the thing that you are relating it with magnetism, no, it is fine, but the way you are explaining it, it is not that simple, right? So you are on the right track, so you can take it as well. Like you can understand it with your like own methodology. But the simplest way is as the two atoms are coming too close to each other, they will repel because their nucleus is about to touch. And at the nucleus, there is high positive charge concentrated, and positive and
Yeah.
positive will not like to come in contact with each other. So when they are just about to touch each other, they will repel with high magnitude. And at this point,
If they
we will
touch,
say, no, they won't be able to. Suppose uh, they won't be able to touch, basically. The moment they will be about to touching each other, they will just repel with very high magnitude.
okay, first of all, I want to know what does negative energy mean and positive energy mean?
See, negative energy means basically the stability. Suppose I am saying my molecule has high energy. Suppose I am saying my molecule has 500 kilojoule energy, right?
Huh?
So I would consider it as very unstable. And as I am moving in negative direction, suppose I am saying my molecule has minus 500 kilojoule energy, right? By minus
Mm-hmm.
500 kilojoule energy, I mean I need to supply 500 kilojoule energy to make my molecule unstable. You can say to make my molecule have some energy, right?
Oh,
The negative signs basically means I need to supply energy with opposite sign to make it basically react, right? Suppose
yeah,
at
too
at
stable.
at this point the energy is minus 500 kilojoule. If I
Yeah.
am supplying 500 kilojoule energy, now my molecule has 0 kilojoule energy, right? As I am moving, like suppose I am providing 550 kilojoule energy. So
So
now my
as
molecule has
the
50 kilojoule energy.
nucleus come together, the
Mhm.
it's just saying that it's gonna get more unstable.
Yes, that's why they will repel.
It's that's what it's the whole diagram saying.
Hmm.
Okay.
So see, this is your minimum potential energy. At this point, we have
Yeah.
more stability. There is a minimum energy state when two hydrogen atoms are so near that their atomic orbitals undergo partial interpenetration. This partial merging of atomic orbital is called overlapping of atomic orbital, which results in pairing of electrons. The extent of overlapping decides the strength of covalent bond. In general, greater the overlap, the stronger is the bond formed between two atoms. Right? The greater
Yeah.
the overlap, the stronger the bond. Like this, if your bond is more overlap, the bond is stronger. But you should not force it to move too close. If you are forcing it to move too close, then it will suddenly push each other away due to very high repulsion of nucleus. Right?
Yeah.
So please read it on your own. Give it few seconds and see if you have
Mhm.
any doubt. This is all VBT. VBT simply says if two atoms are coming close to each other, the attractive forces are dominating, then the bond will be formed. Otherwise, we won't be able to form a bond. That's it.
Okay, fine.
Just give me a second. Let me see some animations out of thing if it is available. Okay. Hmm. Just a second. Hmm, 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 hmm. Sorry, not this.
This topic is kind of complex, huh?
See, this is very simple, and I would do my best so you can understand it with the simplest efforts. Right? See, I think this might make more sense. See, is my screen visible?
Yeah.
See, at this point, when the two atoms are not so close to each other, right, at the right side,
Mm.
the potential energy is near to zero as they are overlapping. Here they are overlapping, right? Optimal distance. The energy is minimum. But if they are coming too close, then the potential energy is again very high due to repulsive forces. Because when they are coming too close, the repulsive force will dominate. And hence, you will see a sudden increase. Is it making a bit more
But
sense now?
what about then? Okay, I understood the too close part and distant part, too far part. But what about optimal?
Optimal means at a point where the attractive forces are dominating. It is the point where uh,
Mm.
the attractive forces are dominating over repulsive forces. It is the optimal point, a point where the bond is strongest, right?
Okay, I
Suppose,
understand, I understand.
okay, good. So let us move ahead then.
Oh, now I understand. So, okay, now I understood what negative and positive means
Hmm.
of energies. Negative means attraction and positive means repulsion.
Yeah, you can say
Um,
that.
Negative means you need to supply energy to stable, right?
It means you need to supply energy. It is already
Yeah,
stable.
that's
If
what
you
I'm
want to make
saying.
it,
You need to supply energy to make
hmm,
it stable.
uh,
So it's attracting. But
yes.
if it's going positive, like highly positive,
Mhm.
you are taking it away from that to stable it.
It is unstable now. Suppose you have now
Yeah,
500 kilojoule energy and you are unstable. But if you have minus 500 kilojoule energy, that means you won't behave unnecessary. You will only start behaving like um, how would you say like
it's
uh,
like it's like give me more something. I
mhm,
want more. Okay, this is too much. Hold on. Okay, this is too much. Can you
mhm.
take back?
Like that, right?
Yeah.
Now let us move ahead. Directional properties of bond. The molecule of hydrogen is formed due to the overlap of 1s orbital of two hydrogen atom when they combine with each other. Why only 1s orbital? Why not 2s?
Which one?
The
Directional properties.
the molecule of hydrogen is formed due to the overlap of 1s orbital of two hydrogen atom. These 1s
Yeah.
orbitals are overlapping. Why? Only 1s, not 2s.
Yeah, because it's one hydrogen molecule, no?
Only one electron is
Oh,
present, right?
Yeah, one electron is present. But why do they use molecule?
When
Shouldn't it be the atom of hydrogen?
no no when
Molecule
two
mean
atoms,
H2.
yes, we are talking about H2, the molecule of hydrogen. That mean H2. When you are
Oh
combining two hydrogen,
yeah. I
coming
understand, understand. Yeah, yeah.
a question again. Which sort
Uh-huh.
of bonds is formed when you are combining two s orbitals? A sigma bond or a pi
Two
bond?
two s orbitals.
Hmm.
Say that again.
If you are combining two s orbitals, which sort of bonds you are getting? A sigma bond or a pi bond?
Two s orbitals.
Hmm.
Sigma bonds.
Good. A sigma bond, right? It would look like
Yeah.
this. The second point. But in case of polyatomic molecules like CH4, NH3, and H2, the geometry of the molecule is also important in addition to bond formation. Right? This
Mm.
is what about directional properties of your bond. Again, a question from this topic is why He2 molecule is not forming. They will ask you, H2 molecule is forming, but why not He2? Why?
Because there's
When you,
already an octet.
yes, but you have to explain it in terms of VBT. What VBT says, a bond will form only when attractive forces are dominating, right?
Yeah.
So in He molecule, when two He molecules are approaching each other, instead of attractive forces, here repulsive forces are dominating. If repulsive forces are dominating, then you what do you would say? The bond is not
Okay, I
likely to be
have an
formed.
idea.
Hmm.
You may be saying the different one, but can I say my
Go ahead, go
like
ahead.
okay? So I am saying it like this, right? As hydrogen, there's like I'm relating to orbitals.
Yes.
As hydrogen has like one s, right?
Hmm.
And one s has like two orbital boxes, right? No,
Okay, good.
not two, one, right?
One.
And it needs two electrons. But hydrogen is 2s, one orbital, and already has two electrons. There's no space. So I'm
So you
saying
are
is
talking about
that
helium, right? You are now talking about
yeah,
helium
yeah,
molecule one.
helium.
Go ahead.
Um, so
You are
you
on the
need
right track.
attractive. So attractive force need to dominate, right? But in helium case, repulsion force is dominating because the orbital boxes are not there.
Good. We can
Um,
go ahead.
so empty, like let's just relate like this, okay?
Mhm.
It's gonna be complex if I explain it in terms of orbital. So let's say oneness as individuals. We need two electrons, right? So let's
Mhm.
take it individual, each electron, each one. Okay.
Mhm. Mhm.
So hydrogen has like one electron, right? It will take one thing, but the other one is empty, right?
Mhm.
Other box is empty, right?
Ah, mhm.
So that box uses attraction force. So in that case, attractive force is dominating. But in case of helium, both are
Mhm.
filled. There's no
Ah,
area to put it in. Like there's
mhm.
no attraction, so the repulsion force is dominating
Yeah,
because
you are
there's
right.
no so I'm saying is that in default
Mhm.
repulsion is there, but if there's like an empty slot,
Mhm.
the attraction will come.
You
It
are
will dominate.
you are basically saying in helium, as they have complete octet, the electrons are basically more, right? And the
Yeah.
other atom has no need of any more electrons. So they will their like inherent tendency would be to repel because they are stable.
Yeah.
A stable species would not want to interact with other species, right? So you are correct.
Yeah.
Your explanation is correct. But when you are
Yeah. But
answering,
I.
you
Yeah.
are correct. But when they are asking in your question about VBT, right? So you have to connect your answer in terms of what? Attractive and repulsive forces, right? You
Mm.
are correct. The methodology that you are using, now you are relating it with ZEF and empty orbitals. That is correct. But you have
With
to answer.
attraction force and repulsion force.
But when they are asking, suppose the same question, if they ask in terms of molecular orbital theory, right? So you have to use the terms that is used in molecular orbital theory, right? So let
Yeah.
us see the things that you have mentioned now. You can see the things that are written here are similar. So let us try to see what is happening.
I'm just bad at explaining things that is
So
in my head.
you explain it very correctly. There it was good.
Yeah, but if you like represent my idea in my head, it will be more understandable.
No issues. You will learn to explain. No problem. The thing is, you are able to like make your you are using your own head to like you are relating the previous concepts and you are merging it with the current ones. It is a good thing.
Mm.
So let us see what is happening when two helium atoms are coming close to each other. This is helium A, this is helium B. So the red ones are repulsive forces and the green ones are attractive forces. So what we are seeing, there are five new repulsive forces and four new attractive forces. So the repulsive are dominating. So we can say when two atoms of helium starts moving closer to each other, four new forces of attractions and five new forces of repulsion come into play. The attractive forces are between the two nuclei and four electrons of the two atoms, while the repulsive forces lies between the nuclei of two atoms and four are amongst the electron. Thus, the repulsive forces dominate over attractive forces. Energy of the system increases and hence no chemical bond is possible. Is this clear what is written?
Yeah.
So this is all about it. Why only H2 molecule exists and Hc, H4 and He does not exist? He2 does not exist. So how can you answer it?
Okay, I have like one. I think it's a question.
Mhm.
Um, I'm just wondering why metals, based on this, why metals uh don't exist, like Fe2 like that.
Fe is not a iron. You are talking about iron.
Yeah,
You are saying why Fe2 does not exist
and why Cu2 not exist.
because of stability. Suppose whenever we are whenever we are producing something or creating something, that species need to be stable. Suppose you are trying to prepare F2 molecule, right?
Huh?
The moment somehow with some extensive methods you are able to produce F2 molecule, but F2 molecule won't exist for a significant period of time. The moment it
Mm,
exists, it will disappear. So will you able
mm.
to study it? The moment you are producing
No,
F2 molecule, it is disappearing due to instability. And hence you won't be able to study it. If you are not able to study it, you won't be able to see its further uses. So this is the reason, because of
but you can make
instability.
predictions.
We cannot, because like if something is very unstable, it won't react the way we are wanting it to. You will see it
Okay,
in
okay.
organic chemistry. In organic chemistry, you will see like if you are producing a charge on some molecule, suppose this is your CH3 or CH4, right? This is
Mm-hmm.
a methane molecule. In methane molecule, what we can do? We can remove the hydrogen, we can convert it into carbocation. And this
Yeah.
carbocation, if you relate it with its neutral counterpart, it is unstable, right? So
Mm-hmm.
uh, we try to use it in some ways to make some other products, right? So in organic
Oh,
chemistry, you will see why something is existing and why something is not. It is all about stability,
something not.
right?
Okay, okay. Yeah,
So
yeah.
this question is again, they might ask you in exam, why only H2 molecule exists? Why H3, H4 or He2 is not existing? So the answer is the hydrogen atom contains only half-filled atomic orbitals, which can overlap with half-filled atomic orbital of another atom, forming H2. No more half-filled atomic orbital is available, and so no more bond can be formed. I think you already told me this. Like in hydrogen, we only have one orbital, and in one
Yeah,
orbital, there is already one electron. So if another atom, another hydrogen atom is coming, it can donate its electron. They can basically make a covalent bond, right?
yeah.
But if another, like three hydrogen atoms are coming close to each other. So if the
Mm,
third one is coming, the two hydrogen atoms don't have availability of orbitals, so they can accommodate electrons from a third one or a fourth one. So the maximum number of hydrogens that can combine with each other are two. So please read this statement and you will be able to
Mm.
understand it because you know what is happening now. Try to read this one now. The first point. Are you able to understand what they are trying to say?
Yeah, but I'm reading it now. H2, no more half-filled atomic orbital is available.
Mhm.
Oh, okay.
You want to see? Let me draw you.
Yeah, I understood. I just understood.
Sure.
Now I'm in second point.
Hmm.
Oh, okay. Yeah, I understood.
Right.
Yeah,
So let us move
it's
ahead.
just what I said,
Hmm. I told you now
but
the things that you mentioned are
little bit.
basically written here. So now let us talk about polar and non-polar covalent bond. Have you heard the
Why is
term?
the quality so bad?
Uh,
It's
is
kind
it?
of blurry.
I think it is readable.
I mean, it is, but I need to look at it so carefully.
Mhm.
No, like the previous page, if you compare between previous page and this page, it's kind of blurry.
No, so see the next
Oh,
ones are
this one
clear.
is also blurry.
This one
This
is
is
better.
kind of clear. Yeah,
Hmm.
yeah.
So you will have up and downs while you will be going through this PDF. So it's life. You have to
Why is there a
bear.
random highlights?
Uh, where
Look,
this is not random
that's fine.
highlight. I have
Huh?
made corrections.
Corrections. What you
Hmm.
made corrections on blank paper? Go down.
Yes, sir.
Just go down. Little bit. Yeah, you blocked it. It's not
There might
coming.
be. Let me see what is written. Okay. Pseudo-novel gas country. This topic is not in your syllabus, so I
Oh,
cover it.
okay. These
So
are
let us see
questions. Okay.
polar and non-polar bonds
Polar and
and
non-polar.
non-polar covalent bond, right? So what is a
Yeah.
covalent bond? So tell me what is a covalent bond?
Covalent bond. Covalent bond is where two atoms share electrons between two atoms.
Equal sharing of electron, right?
Yeah, to make
So
a bond
now we
and
need to
make the
understand.
molecule stable. Yes,
We need to understand the polar and non-polar. Have you heard about the polar term?
I heard of it, but it's kind of.
See, polarity means suppose in covalent bond, ideally the
Mm-hmm.
basically you are hydrogen and I am hydrogen. We are sharing equal number of electron. I am sharing one electron and you are sharing one electron, right? And we are making a bond. Now the two electrons that are contributed by both of us are getting shared by both of us. So I can say I have now two electrons, one of my own, another yours, and you can
Mm-hmm.
also say two electrons, one of yours, another one mine, right? In H2
Say that
molecule,
again.
suppose you are hydrogen and I'm hydrogen, right?
Yeah.
This is hydrogen and this
Continue.
is hydrogen. They are
Mm-hmm.
making a covalent bond. They are sharing these two electrons with each other. So if I
Yeah.
ask this hydrogen, how many electrons do you have? He will say Two
I have
electrons,
my electron and his electron.
right? And if I do the same with him, then he will again say, I have two electrons, one of my own and
One
other
of
one.
them is mine and another one is his.
So this is a basically covalent bond. But the important thing is, now let us try to see what is polar and non-polar. These two
Okay.
hydrogens are same. The electronegativity is same, right? Both of the atoms are
Yeah.
same. So
Hmm.
this molecule is a non-polar covalent bonded molecule. What do you mean by non-polar? That the two electrons are not shifted to a specific position or a specific atom. The two electrons are residing at a equal distance from both of them. The electron density is not shifted to a specific atom because of electron
What do you
negativity.
mean by a specific atom?
Let us take another example for this. Suppose if I'm
Yeah,
talking
don't
about
take
HF,
H2.
HF, right?
Yeah.
For HF molecule, again, hydrogen is contributing one electron and fluorine is
Yeah.
contributing one electron. If I
Hmm.
ask hydrogen, how many electrons do you have? Hydrogen
I
will say
have mine and his.
two. But what about fluorine? Fluorine will say, I have
Mine
now
and
total
his.
8 electron,
Yeah. I
7 my own
have
and 1
seven
from
mine
hydrogen.
and one of them is his.
What is electronegativity? Electronegativity is the tendency of an atom in a bonded state to pull the electron density on itself, right? So
Yeah.
ideally, the electrons were supposed to be distributed in equal proportion, right? But due to fluorine's more electronegative nature, what it is going to do?
What?
It is going to pull the electron density on itself. Suppose now the electrons are going to be more shifted towards fluorine. These two electrons are now more shifted towards fluorine due to
So
its
it's kind
electronegativity.
of a coordinate bond.
Not a coordinate bond, just the electron density. Suppose this is your electron density. Let me show it with a highlight. Uh, where is my highlighter? Hmm, See, this is electron density, right?
Yeah.
This is your electron density. Electron density is
Yeah.
equally distributed. It is not shifted
Yeah.
to a specific atom, but due to fluorine's electronegative nature, fluorine wants to pull the electron density on itself. So now the electron density is concentrated near
There. Near
fluorine,
fluorine.
due to which I told you something about partial positive and partial negative charge. When the
Yeah.
charges are developed only due to the shifting of electron cloud, we will use partial positive or partial negative, as the fluorine is having negative charge, right? As the fluorine is having
Yeah.
what?
Negative charge.
So I will show it like partial negative. It means the bond is not broken. The bond is still intact, but the electron density is shifted towards fluorine.
So if hydrogen says if someone says how much electron do you have hydrogen, it's gonna say
Hydrogen
I
will
have
still
my
say
own and fluorines.
two electron, but how much hold do you have on those electrons? I still have two electrons,
Yeah.
but the electrons are now a bit shifted towards fluorine, right?
So it's kind of hard for him to get it.
Uh, he will say I have two electrons, but in actual they are more shifted towards fluorine. Fluorine is a
Fluorine.
someone who is very what you call those people
Very
who are
electronegative.
electronegative. In normal terms, what we call those people who are very like जो पैसे
Attractive.
ठग लेते हैं दूसरों के like uh, you know what is पैसे ठगना?
Nope.
Let me use some simple word. Uh,
Attractive. I think.
scammers.
Oh, scammer. Okay.
Fluorine is a scammer. He is making hydrogen believe that you are my friend and we are going to share the both of the electron with ourselves. But in actual, what he is doing, he is shifting the electron density on itself.
Uh, okay. I
So,
understand.
so when the electron density is shifted to a specific atom, we say in this molecule there is a polarity. Polarity basically means separation, separation of charges, right? So a molecule, a covalent molecule where the electron density shifted towards a specific atom, we will call these molecules polar molecules, polar covalently bonded molecules.
Okay, I understood what non-polar and polar means then.
Hmm. So tell me, if
You
I
should
am
not
making,
call them scammers. There's a word for it that I shall not name.
you can write it, no problem.
I shall not write it too.
Uh, from which word does it start? Which alphabet?
English.
Which alphabet?
G. G.
G. What's the
You
next
won't
alphabet?
know. I won't say. O.
Which one?
That's it.
G.
G-O. That's it. I'm gonna say. It's in English,
Okay.
but I won't say.
I will search it. No problem.
Don't. I
So
mean, you
it is
can,
clear.
but nothing's gonna come up. Okay.
Okay. So what about this molecule? Cl2. Is it a
Which one?
polar molecule or a non-polar molecule?
Non-polar.
Good. What about this one?
Which
Hmm.
one?
HCl.
HCl. Cl. Polar.
Good. So now you have
Cl
a
is more electronegative
yes.
than
Good.
hydrogen.
So this is about polar and non-polar molecule. Let us see
Chlorine
what
is
is.
most electronegative, right? In the
Yes,
whole
chlorine is the
periodic table.
most
Yeah.
electronegative element.
Yeah.
So let us read it as well. If two similar atoms come close to each other and form a bond by sharing of their electron, the shared pair of electrons are equally attracted by the two atoms as the electronegativity of both is same. When the electronegativity of both is same, the molecule that is going to arise from this bond is non-polar molecule, right?
Mm.
When two dissimilar atoms having different electronegativity combines together to form a covalent bond, the shared pair of electrons shift towards the more electronegative atom, due to which partial negative character acquires by the this atom
So
and
in
partial positive.
exam,
Hmm.
if they ask which one is polar and which one is non-polar, I should say the the different electrons are polar and same electrons are non-polar.
It is not always the case. Suppose there is a specific value.
Okay.
Suppose if the difference in electronegativity is more than 0.5, right? If
Mm-hmm.
the difference in electronegativity is more than 0.5, then you are going to say the molecule is polar. But if it is
Okay.
not, then you will say it is non-polar. So do you have the data of electronegative table of elements with their electronegativity? Try to bring that table and tell me the electronegativity difference between. So before that, is this a polar or non-polar bond?
Hmm.
The
Polar.
atoms are still dissimilar. So you can say polar, right? And if you are
Yes.
saying it polar, then you are wrong. Why? Let us see. Tell me the electronegativity of carbon.
I don't know. 5.
Google it. Google it. Google it.
Okay. Is there a whole table for this?
I have added this table in your third chapter.
2.55.
2.55. What about hydrogen?
Um, I think it's gonna be 1
See,
or 0.
not one, neither
2.2.
zero. Hmm. So what is the difference between the electronegativity? 0.3, right?
Oh, oh, okay, okay, okay. It's
Which
less
is,
than 0.5.
so it is a non-polar molecule, right? Do the same thing.
Oh,
Do the same thing with HF.
HF. Yeah, it's polar.
0.
Of course, it's polar.
What is the value for fluorine, the electronegative value?
The biggest number.
I guess it's going to be around 4. Tell me the exact value. Google it.
3,
4.5 or
4
what?
only.
4. Okay. Now you
It's
can see the differences.
3.98, but I rounded to 4.
The difference is more than 0.5. It is a highly polar
Yeah.
molecule. So now you know which ones are polar molecule and which one are non-polar.
Did I actually say carbon as 5? I did, huh?
Yes, but it is
More
half
than
of it.
fully.
Is it clear?
Yeah.
Just give me a second. Let me plug in the charger. We are going to start our molecular orbital theory, and your chapter is finished. Then we will start thermodynamics, right?
Yeah.
Here's my charger. Meanwhile, try to where is that? Read the ionic character of covalent bond. Okay, so let us talk about ionic character of covalent bonds.
Is
If
that
difference of
1.9 or 1.5?
it is 1.9. Okay, so let us see what is ionic character of a covalent bond. If the difference of electronegativity of two atoms is 1.9, those molecules have 50% ionic character and 50%
In
covalent character.
50% covalent characters.
Okay.
What do you mean ionic character?
Uh, Ionic character means I will use Fezan rules to explain it. Basically, if you have a cation, right?
Mm-hmm.
Cation is something which is positively charged, right?
Mm-hmm.
And if you have a anion is something
Mm-hmm.
negatively charged. So if your cation is small and anion is big, so the interaction, the distortion in the electron cloud is more. If the distortion in electron cloud is more, then the initially considered ionic bond will now have covalent character due to the good overlapping due to the distortion. So I will explain it when we will be talking about Faizan's rule, right? Faizan was a,
Yeah.
I guess, Pakistani scientist who came up with this, like how you can relate covalent bond with ionic bonds, right? So we'll talk about it. For now, try to see it. If your electronegative difference is 1.9, those molecules have 50% ionic character and 50% covalent character. If more than 9, more than 1.9, more than 50% ionic character, less than 1.9, less than 50% ionic character, right? Basically, if the difference of electronegativity is more, then the chances of having ionic character is more. You can take it, just the statement, you should take the statement for now. I will explain it with the animation again. Just see the data for now. I will explain it later, how we are going to use it, right?
Yeah.
Now, dipole moment.
Just a minute. Can you go up?
Mhm.
Okay.
Okay, this is dipole moment is important. There are several questions on this and easy ones. So the dipole moment, the product of magnitude of negative and positive charge and the distance between them is called dipole moment. So basically, if you have a HCl molecule, right? HCl molecule is the H atom and atoms are having distance, let us say d. They are separated by distance,
Yeah.
and this chlorine, due to more electronegative nature, will acquire a partial negative charge, and hydrogen will acquire a partial positive charge, right?
Yeah.
So if we need to define dipole moment, what we can say? The dipole moment is the product of magnitudes of negative and positive charge and the distance between them. Suppose if you are multiplying the positively charged, the partial positive charge on hydrogen with partial negative charge on chlorine and the distance that is separating the two atoms. If you multiply these uh, numbers, these datas, then you will get what? Dipole moment. It is mathematical representation. So
What's U?
U is mu, basically mu. It is a Roman number
Okay.
again. Mu basically represents dipole moment. It's mu,
Okay.
right? So this is about mathematical terms, like what is dipole moment. In normal terms, if you need to understand it, then you can say the dipole moment is generated when you have charge separation.
What is charge, positive charge of hydrogen?
See, it will depend. Uh, if you see the data now, suppose if you are talking about HCl, it will have some different charge. If you are talking about some other
Okay, okay,
molecule,
okay.
so from different molecule, for different molecule, it will have different data. It is experimental, purely experimental.
Okay, yeah.
Okay, for now, are you able to understand in mathematical terms what is dipole moment? If
Yeah.
you are multiplying the two charges and also multiplying it with the distance between them, you will get dipole moment. Now let us try to understand what dipole moment actually means. So we just talked about polarity, right? This molecule is polar. This HCl molecule is polar. And
Mm-hmm.
from where to where the electron density is moving? The electron cloud is more shifted towards which atom?
Chlorine?
Fluorine. So the due to the shifting of electron cloud, we will use this sign. Are you seeing this arrow?
Yeah, I know.
This arrow is basically representing the dipole moment. It is representing the shifting of electron cloud. The density, the electron density is moving from left to right. This is your dipole moment. Dipole moment basically represent the movement of electron density. In simple term, what is dipole moment? It represents the shifting of electron density. It is shifting from left to right. Suppose if I am writing
Yeah.
the HCl molecule like this. So dipole moment is in which direction now? In this direction,
Mm,
right?
yeah.
Is it clear what is dipole moment? Dipole moment is a tool with the help of which we are seeing where the electron density is shifting due to the electronegativity.
Yeah. Yeah, I understand.
Hmm. And the SI unit of dipole moment is debye, which is represented by D. Okay.
Yeah.
Dipole moment is a vector quantity as it has both magnitude as well as direction, right? If you are talking about your HCl molecule, then again, this is your tail. The tail will be towards the less electronegative element and the head will be towards the more electronegative element. This is some data of your dipole moment. For Hi, the dipole moment is more or no. The dipole moment is least for Hi, then HBr, then HCl, then HF. What could be the reason for this? Let me draw. This is your HF. This is your HBr. This is your HCl. This is your Hi. Why the dipole moment for HF is most? Let me give you a hint. If the size is small, the charge density is more. If the size is small, the charge density is more. You can talk in terms of density. What is density? Mass per unit volume. If the
Yeah.
volume is small, then what you can say? The density is high. Or you can simply say if you are placing more charge in small area, then the density is going to be more or not.
Yeah.
If the electron density is more, the formula suggests what? The formula is basically charge into distance. This charge factor for fluorine is highest because fluorine is pulling the most amount of electron density, right? Fluorine is the
Yeah.
most electronegative element. So if
Yeah.
fluorine is pulling the most amount of electron density on itself, then it is having highest amount of charge. And if I am multiplying my charge value with distance, I am getting the highest amount of dipole moment. So this is the reason why
Oh,
HF has highest dipole, right? Iodine, if you're talking about iodine, iodine is again pulling the electron density, but the magnitude or strength with
wait,
which,
bromine is more electronegative than chlorine?
yes, as we are moving down the group, see, this is your fluorine, this is your fluorine, bromine, I made it wrong, I guess. Fluorine, huh, now it is correct. Is it correct now?
Then
Fluorine,
that's
bromine.
wrong, no?
Which one is wrong?
Just look at that one.
Here?
Yeah, HI is the least. HI is less than HBr.
Yes, because iodine has even less electronegativity. Do one thing,
That
try to
I
search.
understood.
Uh-huh. So what
That
should,
I understood. But that is less than HCl.
yes,
Won't it be shifted?
see,
Oh, okay. Yeah, I understood. I understood. Yeah, I just inverted it. Yeah, I thought that was like opposite.
is it clear now?
Yeah, I understood. Yeah.
Good, good, good. So this is about dipole moment.
Yeah.
So now let us see the questions. And this is a very important topic. They are going to
Yeah.
ask you questions on this. And the questions are very easy. So the first question is why BeH2 molecule has zero dipole moment, although BeH bond are polar. They are saying my BeH2 molecule is a non-polar molecule, right? Is a non-polar molecule. But
No, this
the
thing is
bond,
polar.
the bond between Be and H is polar. They are saying
Oh,
why
okay.
BeH2 molecule has zero dipole. Zero dipole means what? There is no shifting of electron density. If there is no shifting of
Yeah.
electron density, then the molecule is non-polar. Although the bond, the specific, see, if I am seeing this whole molecule, if I am seeing this whole molecule is what? Non-polar, right? But
Yeah.
if I am looking only at this bond, I am seeing this bond is polar. So why this is happening? If I am looking at the specific bond, this is coming as polar. But if I'm seeing the whole molecule is non-polar. So let us try to answer it. Suppose for this, I would request you to check the electronegativity of beryllium and hydrogen. Hydrogen is 2.2, right?
Yeah.
What about beryllium? Search the electronegativity of beryllium.
Okay. 1.57. That's the least.
So which one is more electronegative out of hydrogen and beryllium?
Hydrogen.
Good. Now, if I am drawing my BeH2 molecule, why I am drawing it specifically in this manner? We talked about this while discussing hybridization, right? If you
Yeah.
check the hybridization of this molecule, it is going to be what? sp,
Ha-
and sp
Yeah.
molecules are linear. Now, the dipole moment is going to be like this from beryllium to hydrogen because hydrogen is more electronegative, right?
Yeah.
And again from here to here. Now what you are
Yeah.
observing, there are equal and opposite dipole. If hydrogen is pulling the electron density from left to right, the another hydrogen is also pulling the electron density from right to left. So if they both are pulling the electron density with equal force, then the electron density is moving or not. Suppose if we both have same strength and we are pulling a rope, right? If we have both
Yeah.
have same strength, if we are pulling the rope from both of each of our directions, then the rope we are going to move in any direction or not?
No.
No. So this is the reason. Because both of the hydrogens are pulling the electron density with equal force, the electron density is it is not moving basically. Or you can say equal and opposite dipole cancel each other out. So there is no polarity because the dipoles are equal and opposite. Is it making sense?
Yeah. Right. Yeah.
Suppose
Because it's opposite. Okay.
suppose if I'm talking about this only. This is a polar molecule. We will call it polar. But because now there is another hydrogen which is pulling the electron density with equal force. This molecule is non-polar, right? If you have any
Yes,
question,
it's less
please
than
ask.
zero. It's BF2 BH2 is zero, so it's non-polar.
Hmm. This mu is coming out as 0.
Mm.
Now another question. This will for sure. The chances are 70 to 80% they will ask you this question in your exam. Right? So the question
I
is,
have a question.
uh,
Q means charge, right? U is
yes,
equal to Q into D.
yes.
Q means charge, right?
Hmm.
So, Q means the difference between two charges. Is that
Yes.
correct?
Yes.
Um, so the difference between B and two H's is zero.
See, let me show you. See, uh, let us talk about this one only, right? The
Mhm.
value is going to be what? 2.2 minus 1.57, right?
Yeah.
And if I'm talking about the other one, this one,
U is not equal to that. It's actually Q.
I am talking in terms of electronegativity, right? It has
Yeah.
basically same meaning. You can do
Yeah.
that as well. You can do that as well, but for that, no, you need the amount of like the distance value as well.
Yeah.
So see, simply you can say equal and opposite will cancel each other out, and you will have zero dipole moment because the electron density is now not moving at all. If the electron
Mm.
density is not shifting, then we will not have polarity. If we are not having polarity, then we will not have a polar molecule, and the dipole moment is going to be zero.
Okay.
Let me see few more
I
things.
want to know all the formulas for mu, for dipole.
For
It
dipole
looks like
moment,
this, like
the simplest
more
formula
than
is
one.
charge into displacement, and you are going to use it
That I know.
in your
But
12th as well.
what's the other one? Relating electronegativity.
See, hmm, this is your new charge into then displacement, right? This charge is rising between due to what? The electronegativity difference. Suppose there is partial negative charge, there is partial positive charge. Or let me use my fluorine because I know the value of it. Right. Now the difference is coming out to be 1.8, right?
Yeah.
So I will say the charge developed on my fluorine is how much?
Charge.
1.8.
Yeah.
Okay. So I will use 1.8 here. And the distance, I will see the data, how much the distance is. And after multiplying it by my distance, I will get my mu value. This is how we are going to use our electronegativity. The difference of electronegativity, we will use it as the charge. Give me the
Oh, okay, okay, okay,
electronegativity
okay.
of fluorine. Oh, sorry, chlorine.
Chlorine.
Hmm. Is it 3.5?
3 point, let's make it 3.2. Not
Okay.
3.5.
So the difference is how much?
Um,
1.
like 1, yeah.
So the charge on chlorine here is 1. So out of 1 and 1.2, which number is greater? 1.8. If you are
Yeah,
using 1.8 and multiplying it with some value, then the overall dipole moment is going to be larger, right?
yeah.
So this is the
But
reason.
it depends on the distance, though.
See, you will
If the
see some exceptions
distance,
as well. In most cases, suppose CH3F, CH3Cl, CH3Br, CH3I, right? And suppose CH3, CH2F2, CH2, Cl2, CH2, Br2, CH2I2, and so on, like CHF3, CHCl3, CHBr3, and so on. So in your organic chemistry's first chapter in your 12th class, you will see here we have an exception. The
mm,
general order is as we are moving down the group, the dipole moment is decreasing, right? The general trend is As we are moving down the group, the electron density, sorry, dipole moment is decreasing. But in this case, we are observing an exception. As we are moving down the group, fluorine is having a higher value. Suppose if this is 5, then we are getting 7. Then again 4, 3, 2, 1. Here for this one, the order was 5, 4, 3, 2, 1. Constant decrease.
Fluorine is having more value.
For this specific case, for CS3F and CSCCl, for this specific case, the ideal trend is not valid. The chlorine compound, the CH3Cl, is having higher dipole moment value. And the reason is explained on the basis of distance. Here, the distance between the CH3 and Cl is exceptionally high, which is, see, you will learn this in your 12th class, right? So don't worry about it. The resistance is always also going to contribute, but for simpler molecules like HIHF, it is not that significant.
Oh, okay, okay, okay. Yeah, I understand.
So
Can
this
we end the
question,
class at 10?
sure, like,
I mean, in my time.
no issues. Just see this question and then we will end it.
Yeah.
Out of NS3 and NF3, which one has higher dipole moment? So let us try to understand it, right?
Yeah.
I hope I don't need to explain why NH3 molecule looks like this specifically.
Let me see, let me see, let me see.
Tell me the geometry
Oh,
of these
yeah,
two molecules.
yeah, I understood, I understood.
What is the geometry here?
Geometry. Tetrahedral.
Good. What about the shape?
Like, what is the tetrahedral without the head?
Trigonal, planar, or what?
Trigonal planar. Yeah,
No.
trigonal planar.
No. Trigonal, pyramidal.
I think
Pyramidal. Trigonal, pyramidal, right?
pyramidal.
So see.
Trigonal pyramidal.
Hmm. So let us see. They are saying out of NS3 and NF3, which one will have higher dipole moment, and explain it as well.
Mm-hmm.
So let us talk about it. Be careful at this one. Out of nitrogen and hydrogen, which one is more electronegative?
More nitrogen only. I understood this part.
Hmm. So the dipole moment is going to be like this.
Yeah. But
And
between nitrogen and fluorine, fluorine is more electronegative, so it looks like that.
but between a atom and lone pair, we will always show the electron density going from the atom to the lone pair, right?
Yeah, yeah.
Because lone pair is more electronegative always, because it is pure
Mm-hmm.
electron.
Let
Now,
me just a minute, just a minute, just a minute.
so tell me on the basis of these two diagrams, which one should have higher dipole moment? You have to use
Higher
vectors here.
dipole
You have to use
hmm,
vectors. You have to see, the properties of vector. If the vector is in same direction, they will add up. If the vector is in opposite
yeah.
direction, they will cancel each other out. This is basically vector.
Oh, okay, okay, okay.
Which one will have more electron? Oh, sorry, dipole moment. Dipole moment, yeah.
More, huh? I'm gonna say NH3.
The reason is what?
The reason is that it's not canceling out. In the NF3, it is
Hmm.
canceling out because the electrons are taking away from
Good.
all
Very good.
four
Very
of
good.
them
This
is
is
taking away
hmm,
from nitrogen.
this
But
is
in
your.
NH3, it's going to end, but only one is taking away from nitrogen, which is lone pair.
It is basically
Rest
adding
all
up.
are
Suppose,
they going to the yeah, it's adding up, but only lone pair is taking away.
suppose I am pushing the electron density from hydrogen to nitrogen, and
Yeah.
these electron densities are now moving towards lone pair with
Yeah,
intensify.
we can say that we are pushing to a hole,
Mhm,
pushing an electron through a hole.
mhm, mhm.
It goes one
Right.
by one. It's like that. But in the NF3, it cancels out.
Yes. This is your. explanation, and it is written
Lone
over here.
pair is much electronegative that it can cancel out even three fluorines, right?
See, here you shall not
Is
say
it
the
infinite?
dipole. No, no, no. See, they are basically asking which one has more dipole moment. For this
That
one,
I
the dipole
understood.
moment is still not zero. The dipole moment is not zero. But
Okay.
because the dipole moments are acting in opposite direction, there will be some lesser value, right? Suppose
Yeah. Oh,
if
like
you
that, like that. Okay,
hmm,
okay.
hmm,
Less dipole moment. Okay.
see, suppose on the left hand side of your rope, if you are in a tug of war, on the left hand side you have no competition. Four people are
Yeah.
pulling the rope, so the rope will be more shifted obviously without any trouble. But suppose if
Yeah.
one person is pulling the rope from the right direction and three persons are pulling the rope from the right direction, so the rope will be shifted towards